Okay, so today we're going to be learning about special triangles. Now, special triangles are not special in the sense that there's anything fancy about them or that they give you any extra insight into the world. They're just special in the way that we write them. Now, 30, 60, 90 triangles and 45, 45, 90 triangles are the two types of special triangles we're going to be covering today. And the reason why they're special, like we said, is the way that we write them. The ratio of their sides are going to be three numbers that we can write finitely, meaning I'm not writing out some decimal forever, or I'm not having to get it in terms of something else. With a 30, 60, 90 triangle, I know that one leg is going to be of length, let's call it 1. This is the basic one. The hypotenuse is going to be double that number, so 1, 2, and the other leg is going to be that value times the square root of 3. In this case, 1 times the square root of 3 is square root of 3. So I write 1 to square root of 3. Same with the 45, 45, 90. With this, I have both of the legs are equal to each other, and the hypotenuse is equal to that length times the square root of 2, in case 1 times square root of 2 is just the square root of 2. Now, that is what makes them special, is I wrote this. If that was 31 degrees, this would be a little bit taller. It might be like 1.0111. It'd be some really long decimal that I wouldn't be able to write as simple as just one stroke of the pen. This might be, because that's a little bigger, this is probably going to be a little shorter. We're not really sure what that would do to that length right there, but this would shrink up just a little bit. And your response might be, well, yeah, this might be some big long decimal, but isn't the square root of 3 equivalent to some really big long decimal, or isn't square root of 3 considered irrational? And the answer would be yes, that is correct, but I can write it finitely. So in the end, special triangles are a way to write relationships with concrete numbers that aren't in terms of something else, and it's as simple as just memorizing this relationship. Let's go ahead and take a quick look at some of these problems coming up. So if you see a triangle like this on number 1, we notice the fact that I have a length 1 and a length 2, double the length. What I'm going to then take a look at is say, okay, if it's double the length, is my length that's doubled, is that the hypotenuse? The answer is yes. Okay, so that should be very close to my 30, 60, 90 triangle, which means if that is a 1, that's going to be a 2, and that third side must be the square root of 3. And then I'm going to look on the inside. I'm going to say, okay, the shortest leg, which is going to be my 1, is opposite the 30-degree angle. The other leg is going to be opposite my 60-degree angle, which means that my answers in this case, my x is going to be 30 degrees, and my y is going to be the square root of 3. Perfect. That's it. If I look at another one, I'm going to come up with a very similar situation. Now, in this case, my triangle looks like it's flipped around. It's not in the same orientation, but that doesn't mean that they can't be related. So I'm going to take a look at this and say, okay, I see some angle length of 60. Okay, that must mean that this is going to be a 30, 60, 90 triangle, not because I remember this relationship, but because I know that the angles inside a triangle have to add up to 180. I know that's 90, which means that 180 minus 90 is going to be 90 degrees for these two. That's 60, so 90 minus 60 is going to be 30. That's all that's left for the inside of a triangle. Then I'm going to look at the sides. Okay, I know the side opposite the 30-degree angle is going to be 1. Let's make sure that that is the same relationship right here. Yes. Okay, cool. So that must mean that that is of length 1, which means that this is double that length 2, and this is that length times the square root of 3. Perfect. So I know in this case my x is 2 and my y is 1. Awesome. Move on to a different type of triangle, the 45, 45, 90 triangle. Before I even look at anything else, I see the fact that I have 45 degrees. So I know I have 180 degrees, I have 90 degrees, I have 45 degrees left over for that corner. So this must be a 45, 45, 90 triangle, which means that if this is the hypotenuse of square root of 2, that must mean that both these legs are both 1. So I have an x equals 1 and a y equals 1. And there we go. And then the last part is just what happens if the triangles are reoriented. Again, it's no different than what we had on number 3. It's just going to be flipped around. So we're going to take a quick look and see if we can't relate these to anything else. So I see my triangle and I say, okay, I have one leg of length 1 and one leg of length square root of 3. Well, I know that if I multiply 1 times the square root of 3, I get the square root of 3, which means this must be a 30, 60, 90 triangle. So I'm going to take a quick look and see, okay, it's a really skinny 30, 60, 90 that I drew there. If I have a 1, 2, square root of 3, let's orient that. Okay, so it looks like we've just rotated it about 90 degrees. That is now vertical, and that is now horizontal, which means that this y must be of length 2. And then what's opposite the 1, the angle that's opposite the 1, or the angle that includes the 1, must be my 30 degrees, which means this must be 60. So we know the fact that we have an x is equal to 30 degrees and a y that is equal to 2. So now that you've seen a few, what I want you to do is pause the video, try out number 9, and see if you can't get it. Unpause it when you're done and see how well you did. Okay, now that you've had a shot to try it out, let's take a look. You see 60 degrees and you know the triangle adds up to 180. So I have 180 minus 90 is 90, minus 60 is 30. So that angle must be a 30-degree angle. And then I know, okay, I have a 30, 60, 90 triangle. So what I'm going to do is I'm going to say, okay, if I have a 30, 60, 90 triangle, I have 1, 2, square root of 3, which means that, okay, my hypotenuse is 2, so it's exactly this triangle. I just need to figure out how this is oriented. Well, if I rotate this, I'd have a 60-degree angle over here. It's not, so it looks like this is rotated and flipped over. So I'm going to say, okay, this must mean that this is length 1, because opposite my 30 degree is my length 1. Opposite my 60 is going to be my square root of 3. So in this case, I know that x equals 1 and y equals the square root of 3. Boom. There we go. So now you might have been asking, like, okay, why am I concerned with checking the fact that we talked a little bit about, well, if this is times the square root of 2, does this work? If this is double that length, if this is double that length, why don't I just remember the numbers 1, 2, square root of 3, and why don't I just remember the numbers 1, 1, square root of 2? Shouldn't that help me out? In some cases, yes. If you do have a length 1 in those positions, yes, that would help out. But what happens if you have this triangle that's twice as big? Those aren't going to change what's on the inside. But if that's twice as big, this is going to be a 2, a 4, and that's double whatever that will be. Not going to remember that. What happens if it's 3 times or 4 times or 3.5 times or the square root of 2 times bigger? You're not going to be able to memorize all the different ratios of sides. So what you're going to do is you're going to notice double the length multiplied times the square root of 3, which is going to bring us to the next set of triangles. Let's take a look at number 10. Number 10, we have a triangle that I see a 45, so I know 90, 45. So that must mean that this is 45 degrees. That's a 45, 45, 90. So if I draw my 45, 45, 90 triangle right here, I know 1, 1, square root of 2. And that looks nice, but that's not a square root of 2, so they're not the same triangle. But they're similar. There's something that if I took this triangle and just made it 5 times as big, boom, I'd get that, because square root of 2 times what gives me 5 times the square root of 2? Well, you'd get it if you said times 5. So what I'm going to do is then I'm going to take every length of this triangle and multiply it times 5. So I'm going to say this is equal to 5 times, equal to 5 times whatever the original triangle had, times 1, times 1. Okay? So that must mean that my x is equal to 5, and my y is equal to 5. Boom. There we go. So we're instead focusing on finding the scale factor, because even though it's not the same triangle, it has the same relationships. So let's take a look at the next one. Number 12. Now number 12, I don't see any interior angles, so it doesn't clue me off on what type of triangle it is, but I do notice I have a leg that is 4 and a hypotenuse that is 8. That's double that length. Which special triangle do we know that one leg length doubled is the hypotenuse? If you said 30, 60, 90, you would be right. So if I have 1, 2, let's turn that into a square root of 3. They're not the same triangle, but I'm going to see if I can't find a scale factor. So I'm going to say 1 times what gives me 4? Well, 1 times 4 gives me 4. Let's check to see if that's consistent. 2 times what gives me 8? 4. Perfect. So this must mean that this is 4 times the square root of 3, which is just 4 square root of 3. And now, would I multiply the angle measure times 4? Because that would mean that's 30 times 4. Well, no, it wouldn't, because first off, we would know, because 30 times 4 is 120. 120 plus my 90 is 210, which is more than the length, more than the 8 degrees inside of a triangle, so I can't do that. And realistically, I wouldn't, because I know that this triangle has a 30-degree angle measure right there. Doesn't matter how long these legs are, that's still 30 degrees, which means it doesn't matter that these legs are 4 times as long. That is still opposite my shortest leg, which is going to be 30 degrees, which means this must be 60. So my x is 30 degrees and my y is 4 square root of 3. Awesome. So now that you've seen a few, I want you to go ahead and try out number 14 and number 16. And now, depending on which version of this you have, you might have a 1. Go ahead and change this to a 2. The original version of this had a typo on it, and I fixed it for the video. But go ahead, pause the video. If you have a 1 right there, just go ahead and write over a 2 and give it your best shot. Unpause the video when you're done to see how well you did. Okay, so let's take a look at what you might have done here. So I'm looking at this and I see the fact that I have a square root of 2 and a 2. This could be a 30, 60, 90. It could be a 45, 45, 90. It could be a 46, 44, 90. I don't know. So I'm going to take a shot in the dark and I'm going to say I see a square root of 2. I know that the 30, 60, 90 tends to have square roots of 3s or some variation thereof. The 45, 45, 90 is going to be the better option. And so I'm going to see if I can find a consistent scale from this to that. So I'm just going to pick a side. So I'm going to say, okay, I'm going to say 1 times what gives me the square root of 2? 1 times the square root of 2 gives me the square root of 2. So I'm going to try that out on the other side that I know, the square root of 2. So I'm going to say square root of 2 times what gives me 2? Let's try out square root of 2. And so let's see that. Does the square root of 2 times our scale factor of the square root of 2 give me a value of 2? Well, this is the square root of 2 squared, which is 2. Yes, so this is a 45, 45, 90 triangle scaled up by a factor of square root of 2. So let's go ahead and check out a few of these relationships. Well, if this is the square root of 2, that must mean that this is also 1 times our scale factor of the square root of 2, which is going to give us just another square root of 2. We could also know that those are always going to be the same value. And that, as we discussed prior, isn't going to change because no matter how long or how short these legs are, that angle measure isn't going to change. So that angle measure is still going to be 45 degrees. My y is going to be the square root of 2. And so the last one, let's take a look at number 16. Number 16, same idea. I'm going to look at this and I see, oh, I have a 30-degree angle right here. That must mean that this is going to be 60 degrees. So my first thought is, if I have a 30, 60, 90 triangle, I'm going to have 1, 2, square root of 3. So I know the fact that if I have my shortest side, or my length opposite 30 is 1, my length opposite 30 here is 100. So I'm going to say 1 times what gives me 100? Well, the answer is 100. So I'm going to see if I can't multiply the other two values. So I'm going to say if this is 2 times 100, this should be let's write this over here, this should be 200. And this opposite 60 is going to be square root of 3 times 100. So square root of 3 times 100, which gives me an x is equal to 100 square root of 3. It doesn't change. And then we've discussed that no matter how big or small this angle measure, this is going to stay 60 degrees. And there we go.